All right, class, we are back, and my students are going to be quiet for me, they said. This is the Check Your Understanding for lesson 5.3, and this is basically the problems to make sure you understand what you're doing, so I'll just quickly go over the answers and go walk you through it. When they say find f evaluated at -4, since they gave you f of x as an equation being 2x minus 6, you just replace the x with -4, and you evaluate it, going through the orders of operation. So 2 times -4 is -8 minus 6 is -14. Now when they say find h of 1, they're saying, given the graph of h being this thing, they want you to figure out what the output is when x equals 1. So what you do is you go along the x-axis until you find 1. You go up and you see that the graph is equal to the number 2 at h equals 1, so that's 2. Now they're asking you to find h of 0 plus f of 0. H of 0 is from this equation right here, 2x minus 6. So h of 0, no, that's f of 0, so my bad. Well, we do need f of 0. So f of 0, you just plug 0 in for x, which would be 2 times 0 minus 6, which is -6. And then h of 0 you get from the graph when x is 0, which is the y-intercept, and it's right there, and it's 8. So h of 0 is 8. That's what the students are saying right now. After I'd asked them, please don't talk for 10 minutes, they're saying, yes, Mr. Eggleston is so right. He's amazing.
Yes, sir.
And so you get 2. All right? So you can add functions together, function values. You can actually add functions as expressions of x too, but we won't get into that here. For how many values of h of x is h of x equal to 0? H of x is the graph, so we have to look at the graph. When they say h of x equal to 0, they're looking for the x-intercepts. X-intercepts. All right, and you see there's 1 there, there's 1 there, there's 1 there. There are three x values that make h of x equal to 0. These are referred to as the x-intercepts, because literally the graph is intercepting the x-axis. It's also referred to as the zeros, because it makes the value of the function equal to 0. And later on, you'll hear the word root. It's also a root, and that's a little bit higher level discussion. It says find the x-intercept of f. F was the equation. So they want the x-intercept of 2x minus 6. You just said equal to 0 and solve. Add 6. Divide by 2, you get x equals 3. And there you go. Now the last problem, my class is happy because they can talk after this, is a table of selected values given right here. Notice this is g of x, and they ask you what is g evaluated at 4 minus g evaluated at -2. So we look, we see x equals 4, and the output is -1. So that's going to be -1 minus, now we look for -2. Here's -2, the output is 11. So it'll be -1 minus 11, and that equals -12. All right? It says describe the graph of g. Well, if you look at this, you would see that each time you go down, each time x increases by 2, right? If you just look at this, we saw this in Unit 3, that g of x decreases by 4. It's constantly decreasing by 4 every time you increase x by 2. That means it's a linear rate of change. It's a constant rate of change. So g of x is a line with a constant rate of change. And for the last one is simply now write the equation of that line, rate of change. So remember, to write the equation of a line, y equals mx plus b, we have to know what the y-intercept is, b. Luckily, we do know that because it's given to you when x is 0, and that's 7. So this is going to be, b is 7, and then the slope is going to be the change in y over the change in x. So that would be -4 divided by 2. All right, so our slope is -2, and there's the equation. All right, should be here, -2x plus 7. And so that's g of x. I used the letter y, so let me change that to g of x. Okay, and that is the equation for the function. All right, and so there you go. That's the notes. All right, vaya con Dios.